Hello everyone. In this video, we are going to see the topic on naive-Bayes classifier with the simple example. In the previous video, we know that what is a naive-Bayes classifier. Before going into that classification example, first we have to understand why we need the naive-Bayes. So, because we are handling the categorical outputs and work with the probabilities, and we have to do the efficient classification in the large amount of data means we have to need the naive Bayes classifications. So naive Bayes is mainly used in terms of probability based problems. After that, first we have to understand what is the naive Bayes classifier. So naive Bayes classifier is a supervised learning algorithm. It is a classification model based on the Bayes theorem. It is mainly work on the basis of Bayes theorem concept with the assumption of independence between each features. So we have that formula like the probability of C or C means what is the probability of C is the posterior probability. So the naive Bayes classifier find out the posterior probability from the prior probability and also the evidence. So the P of C bar X is equal to P of X bar C. So the X bar C is the likelihood occurrence of the particular event, and P of C. So P of probability of C is the prior probability of the particular class divided by probability of X. So the predicted prior probability of the particular X. So this is the main formula is used to find out the naive Bayes classification. So here we can see the one example of that is that example shows that we have the features like outlook, temperature, humidity, wind. Based upon that four features, we have to find out whether the particular tennis is played or not. So totally we have the 14 data. Our input is that we have that whether the particular outlook is sunny, temperature is cool, and humidity is high, and the wind is strong means. So what is the class label of the particular data? So we have to classify the particular new input using the naive Bayes classifier for the particular example. So the first step we have to find out the probability of the whole class labels. So the probability of closed label means, so in this example, what is the class label? So the class label is a yes or no, isn't it? So we have to find out the probability of and then occurrences of now total number of yes and total number of n in the out of 14. So the probability of played tennis which is equal to yes, which is equal to number of yes divided by total number of occurrences, which is equal to 9 divided by 14 is equal to 0.64. Next is we have to find out the probability of no. So the probability of no is equal to number of occurrences of no in the total data set divided by the total number of occurrences. So the 5 divided by 14 is equal to 0.36. That is the probability of no occurrences. So the first step we have to find out the total probability of class labels. After that we have to find out the probability of each features. So finally first we take is at outlook is the first feature. So in the outlook, how many features is there? We have the features like sunny, overcast, and rain. So the sunny, overcast, and rain, we have to find out the occurrences of yes and no. So the first table shows that for the particular feature outlook, the three instances sunny, overcast, rain, occurrences of yes and no. So same thing we have to find out that temperature. So in the temperature we have the two what are all the features is the particular temperature attribute. We have the features like hot, mild, and cold. So the particular hot, mild, and cold, what is the occurrences of yes and no? And next we have the humidity. So in the humidity we have the two features. One is the high and normal. So we have to calculate the probability of high and normal yes and no. So next is the windy. So the windy we have the two features like strong and weak. So we calculate the yes and no occurrences of the particular strong and weak. So this is the probability of individual features. So the first step, we have to find out the probability of whole class labels, like the class labels in the particular example is yes and no. Next, we have to find out the probability of particular different class labels on the particular features. So after finding the probability table, we have to calculate the probability of yes and probability of no in the particular data set. So what is based upon our input? So our input is outlook is equal to sunny, temperature is equal to cool, and humidity is equal to high, and wind is equal to storm. First, we have to calculate the probability of yes for particular sunny, temperature, humidity, and wind. So the probability of occurrences of yes for the particular features sunny, cool, high, and storm, we have to calculate based upon the previous table. So the outlook, the probability of yes is equal to 0.0053. So this is the probability of yes of the particular given input. Next, we have to calculate the probability of no for the particular given input. So that particular probability is calculated based upon the previous step. So what we have to find out means we have to find the two probability of yes and no. So in that particular probability, which probability has the highest percentage, that probability, that particular class label is assigned to the given data class labels. So this is the way we have to calculate the classification label of the particular given input. So let us summarize that what we have to done so far is we have to find the classification based upon the Bayes theorem. First, we have to predict the conditions of outlook, temperature, humidity, and wind. So that prediction is find out based upon that, calculate the probability of playing tennis and not playing tennis based on the particular conditions, and compare the probability and choose the outcome with the highest probability. So in the particular thing, which probability has high means that could be assigned to the particular thing. So the probability of yes is 0.54 and probability of no. So based upon that, we have to find the class label of the new input. I hope you will understand how we can calculate the classification label of the particular input using the naive Bayes. Thank you.